Hi all. In our previous tutorial, we have added environment, we have added boxes, but the box are not in the environment. But if I will play on the beat, it will print some values, right? So what we will do, we will spawn the boxes. So we have this box spawn manager. So what we will do, we will choose out of these four a random arrow and we will spawn a box on that beat. So if I will go to the rider, if you remember, we created the spawn manager. So I will have the reference of mbox base, the class, u property, edit anywhere, and it will be the t subclass of, and it will be the type of a mbox base. Include box class. Actually, I will just remove it and will add the forward declaration to it. And I will add the actual header file in the CPP. Okay, this is nice. Go to the CPP. So if you remember, this is where we are printing the value. Here we will spawn our main actor. So there are two types how we can spawn it. One is the simple spawn actor. Get role spawn actor. So we have two functions. One is the spawn actor simple and spawn actor deferred. Deferred means here if you do have any parameter, if you do want to initialize it before calling constructor of this class, then we will use spawn actor deferred. And we know in boxes there will be the two type of boxes, and when we are spawning them, I do want to declare like whether it's a red one or the blue one. So here we will do it before calling the constructor. We will assign the value of red and blue. So that is why I'm calling using this function spawn actor deferred. And here we will have the box class a ham box space. Mm, Second thing, I'm not sure if we'll use this variable or not because I don't think like we are using anything in the blueprint variant of it. So I can directly, put the AM box base static class like that. Or if you are doing something fancy in the blueprint, then you can use this variable. I will just remove it for now. Comma, here we have to give the transformation. I do want to spawn our actor. So right now there are four component, right? In spawn manager we have default root. Okay, I haven't added these four to the C++ variant. So what I will do, I will just use the default scene root for now. Okay, I will add it in the C++ variant. So get actor transform. Next is what variables I do want to edit it. Okay, first I will save it. Box to spawn. Okay, next here I will go to the box. I haven't created the box type. The color types I will do the same. Control D. Instead of this, I will use the color type. E color type. Add it. Color type. Okay, now it will be the T enum as byte. E color type. Here I will assign a random one. So box to spawn dot color type So we'll use rand 2 because we know the length of color type is 2, and static cast. Don't think it will work. Will it? Give me a second. Let me check. I haven't tested it yet. No. So I will directly cast it to color type. Once we have assigned the color, now we will spawn it. So how we will do it? We will directly call box to spawn, finish spawning, and again we have to give the transformation. So get actor transform, and then so it will assign the color. So right now we are not doing anything when we are assigning the color to it. So in the header file, when we are assigning the color, what we will do, I will again, you know, use the same blue and red color code. So go to the spawn here, copy this code. I'll paste it in the box. Copy box header alto, and again we'll use the same code to assign it in the box. If the box type, we'll remove this. If the color type is red, then we will assign the material red, else we will assign the material blue. It should do the task. Next thing, when we're spawning manager. So let's test this code first if it is working fine or not. And okay, let's test it. Compile. Okay, it's successful. Let me drag it. Compile. Sorry, simulate it. I think it is working fine, and there are lots of boxes because I was keeping eye on this number of actors. It was increasing one by one. So our next task is to to push the boxes in the x-axis. So what we will do, again we will go to the code. In the box side, we will write the code to move the box in the forward direction. So let's do that. So here we will use the timeline. So I have just in the box to use the timeline in the C++ variant is it's quite different how we usually do it in the blueprint version. So first we have to define some variable. Let's do it here. First is the f timeline include, and here we will box move timeline. View property, edit anywhere. Here we are defining one variable u curve float curve. This is the main main variable which will drive the animation. Next is the event. So f on timeline event. This is the finish event. F on timeline float, and this is the float event. So progress update with alpha. Okay, so these are the two event. This will be called when the event will be finished, and this is the one float event. It will give you the alpha, and it will call on every tick. Okay, this seems perfect. Now we can move to the C++ CPP from header file. So here what we'll do first, we will attach all the codes in the begin play. So what we will do first, progress update with alpha, bind dynamic. This so here we will attach this uh, to function. So and am box base colon colon on update on timeline update. Update. Next, we have to do it with the finish event. So finish event dot bind dynamic. Again, we have to do the same thing which we did on finish on. We will follow the camel case timeline finish. Next is we have to connect the curve, float curve, you remember, which we defined with this progress update. So some timeline dot add in the float curve, float curve progress with 1 alpha. Next timeline dot finish. Here we will attach the finish event. So finish event. Next is to run the timeline start from play from start. Okay. Okay, so I will just repeat it one more time what we are doing. So timeline, when you define it in the blueprint, let me open this, right? So if you will do it here, timeline, here you have a function called play from a start, and when you will double click it, it will create, it will ask you to add the curve, right? So here for the curve, I'm using the this float curve, which we are attaching it here, float curve. So this will attach it, and here in the blueprint when we usually call update, so this is the binding for it. So this will call the update function with alpha. So these are the two binding, and this is play from a start, play from a start. Okay, I'll just remove it, compile and save. We'll press Alt Enter. No, click Alt Enter, create member. We'll do the same with finish, Alt Enter, create member. It will generate these two function, Alt Enter again, generate definition. It will generate the definition in the C++ variant. It will give you the alpha. So this is the alpha. You can change the output to alpha. So it will give you the idea what this variable is for. And this will be called when we will, finish the timeline. As soon as we are done, we will, when the timeline is finished, we will destroy this actor. So destroy, we'll call that destroy. Here we will call the UE log just to check if everything is working fine or not. UE log, log temp, warning, log. Update with alpha, %f, comma, alpha, close. Okay. Nice. So when this timeline will be called, I do want to move this box 1,000 units for in the forward direction. Sorry, in the negative direction. So how we will do it? I will set the location. So set actor location. Here we will need to the f vector, and here will be the x value, y value, and the z value. So x value we will change it, and y and z, it will remain the same. So get actor location dot y, get actor location dot z, it will remain the same. I will have a variable private and it will be a float current x position. So when we are starting it, so I will initialize the x position. So current x position, we will define it in the begin play. So here I will do it. Default current x position. We will initialize it with the get actor location dot x. As soon as when we are updating the value, we will change the current x position is equals to current. Nope, 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 nope. It will be another. So value to move is equals to current x position plus alpha into distance to move. Okay. By default, I'm just keeping it to 1000 or negative 1000. Okay. Alpha into distance to move. And it will not be the current, it will be the default. So control R default. Control R default x position value to move. So what it will do, it will move the box from here to here according to our curve. Okay, it seems fine. The only thing which we have to, put is the curve, float curve. We haven't done it yet, right? So when we will compile it, it's done. Go to the box, actor, try the box. Here we have the, float curve. Which, no, I don't want this. Let's show plugin float. Actually, we can create our own. So I will just go to the data, assets data, right click, and we will do it will be the part of miscellaneous curve. Choose curve float, select box move curve, double click it, open it, and here with 0 0, click add one key, 0 0, or add one more key, and after 2 seconds, actually I do want to have it. So right click, add key 2, and the value will be 1. So it will be the linear curve. Compile and save. Will remove from plugin box move curve. Okay. Mm, Now, but we are not using a blueprint variant here, right? So we have to get the reference of it here, like in the C++. So copy reference. This is the box, right? So I will just, when we are loading it, I will just load one more value. I will just remove it. How we were, loading the material instance, the same way we will use the curve float. So float curve. ucurve float, ucurve float. Now we are loading the value of float curve. If it is not valid, then we won't do anything. If it's valid, then it will go forth. Else we will, print the value. Float curve value is not defined. Please check it again. Perfect. Uh, Everything seems perfect. Okay, one more thing. Actually, this, you know, the timeline, it has to be aligned with the tick function. So we will do that too. We haven't defined tick here, is haven't we? So virtual void tick. Okay, alt enter. Then tick function will do timeline box timeline dot tick timeline. Here we have to pass the delta seconds. That's it. Now it should work perfectly. Compile. Let's play. Things are moving, and it seems they are moving in the correct direction, but there are few flaws. One is the size of boxes, they are twice, and second, I don't see the blue and the red variant to it. So we will fix in the next tutorial. It's already 22. So thank you and have a nice day. If you have any doubt, just let me know and I will try my best to fix it as soon as possible. Bye bye.